On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to find the maxima or minima of a function involving an exponential, and we have g of x right here, and we want to find the maximums or minimums of this function. In a previous video, we took this same function here and we found the critical values of that particular function. So go check this video out. We found the derivative. We set the derivative equal to 0 right here, and then we found one critical value. So that's where this information here is coming from. So we're picking right up from where we left off in the previous video. Here's that same derivative that we found. And now let's create a number line with some test values. So here's our number line, and I have 2 on this number line because when x equals 2, the derivative of g is equal to 0. And what we are concerned with is the sign of the derivative. If the derivative is positive, our function is increasing. If the derivative is negative, our function is decreasing. And recall, if we have a function that goes from increasing to decreasing, the function's increasing here, and then it starts to decrease after this, we have a maximum. If a function goes from decreasing to increasing, such as what we have here, decreasing to increasing, we have a minimum. Now the derivative at this particular spot and this particular spot, the derivatives are equal to 0. So that's what we have going on right here. Now there is a chance that you could have something like this as well, perhaps, maybe like an inflection point, but we'll look at that later. For now, we're going to be dealing with something like this or like this. So let's pick our test values. Anything to the left of 2, such as 0, and anything to the right of 2, such as 3. Now, all we care about is the sign of the derivative. So let's take our test value of 0 and let's plug it into this derivative. Now we can do this without a calculator because all we care about is the sign. Is it positive or is it negative? If we plug 0 into here, we get e to the 2 minus 1/2 times 0. Well, this just becomes e squared. E squared is positive. Times, what do we get when we plug 0 into this part? 1 minus 1/2 times 0, well, that's 1 minus 0, so we get a positive. Therefore, a positive times a positive, we get a positive, which implies our function is increasing. Now let's repeat this process for 3. If we take 3 and plug it into here, 2 minus half of 3. Well, we're going to get e to the, it doesn't really matter, e to any power is always going to give you a positive number. If you take e and raise it to any real number power, you will always get a positive number. If you don't believe me, grab your calculator and take e and raise it to a negative number, take e and raise it to a positive number. You always end up with a positive number right here. Let's multiply this by, what do we get when we plug 3 into here? 1 minus half of 3. Half of 3 is 1.5. 1 minus 1.5 is a negative number. And a positive times a negative is equal to a negative. Therefore, our function is decreasing on the right side of 2. So here's what we have going on. Something like this right here. Our function goes from increasing on the left side of 2, like this, and then it starts to decrease on the right side of 2. Therefore, when x equals 2, we have a maximum. And we're going to verify this on a graph right here in a moment, but let's go ahead and find that maximum right now. And therefore, to recap one more time before we go and find this maximum value, the function is increasing from negative infinity to 2. That's what we said right here when we picked this test value. So from negative infinity to 2, the function is increasing, and then from 2 to infinity, the function is decreasing from here to here. And since we're going from an increasing to a decreasing function, we have a maximum at this critical value of 2. That maximum value is, well, what we want to do here is take 2 and you want to plug it into the original function. Do not plug it into your derivative because that's going to give you 0, remember? And when we plug 2 into x, we get a maximum value of roughly 5.437. And here we have this g of x, and for values of x from negative infinity all the way up to 2, our function is increasing. And then from values of x from 2 on to positive infinity, the function is decreasing here. And as you can see, at 2, we have this maximum value of 5.437. And there you have it, looking at intervals of increasing and decreasing for a function that involves an exponential piece to it. We found the derivative and set it equal to 0 in an earlier video, and now we're reiterating the fact that a function that changes from increasing to decreasing, such as what we had here, that implies we do have a maximum. And then we did follow up in the TI-84 to find that maximum value. And then we looked over in Desmos and saw that curve as well to verify our answer. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.